I am Khumalo Smangele, an analytical chemistry student in the University of Johannesburg, and we are doing a presentation pertaining the removal of microplastics and heavy metals in freshwater and wastewater system utilizing the advanced membrane technologies. Be introducing my group in the order that we will be appearing in this video for this presentation. I, Khumalo Smangela, I will be doing introduction with Sibulela on methodology, patience with discussion, today's sober results, and gift during the conclusion. So without further ado, let's get into it. Water pollution from plants and microplastics poses serious threats to both humans and the environment. Microplastics can absorb toxic heavy metals like zinc, copper, and arsenic, which can cause cancer and affect the reproductive health. The study aims to develop a method of identifying and removing these contaminants from water using polyvinyl iodine fluoride membrane modified with carbon nanoanions.
There are 5 steps that we followed in this experiment. Step number 1, which was water sampling, where samples were collected from a wastewater treatment plant influent and effluent from the lake and water and tap water sources. Step number 2, microplastic separations, where microplastics were separated from the water using PVDF and CNO membranes. The microplastics were quantified and characterized using tools such as a stereo microscope and scanning electron microscopy. Step number 3, heavy metal analysis. Heavy metals attached to the microplastics were extracted using acids and ICP-OES. Step number 4, filtration. Water samples were filtered using PVDF membranes and PVDF membranes modified with carbon nanoanions, which is CNO. The filtration process involved passing a known volume of water through the membranes. This allowed the microplastics to be trapped on the membrane surface. Step number 5, weighing the microplastics. The membranes were weighed before and after the filtration process to determine the mass of the microplastic captured. After filtration, the membranes were allowed to dry for 24 hours before re-weighing. Now this is just a picture to show you how microplastics are removed from water.
The discussion emphasizes the need for improved wastewater treatment, as current processes do not fully remove microplastics or heavy metals they carry. Microplastics act as carriers for toxic metals like arsenic and copper, posing environmental health risks. While PVDF membranes are effective, PVDF and CNO's membranes face clogging issues, limiting large-scale use. Overall, better filtration systems are necessary to tackle both microplastic and heavy metal contamination in water.
The results shows the peak concentrations of microplastics in wastewater compared to treated samples like tap water and lake water. This shows the efficiency of PVDF and CNOs in removing microplastics and offering significant filtration of water. The detected microplastics include nylon 12, cellulose, and HDPE. The presence of microplastics in water causes heavy metals to be present and in high levels, with copper being 83.176 milligram per liter and arsenic being 8.699 milligram per liter, high above water limits. The study shows that improved water treatment plants need are needed significantly to counteract microplastics and heavy metal contaminations.
To conclude, this research highlighted the importance and the need for advanced water treatment solutions to address microplastic and heavy metal contamination. Using modified PVDF membrane, the research successfully removed both pollutants, demonstrating the potential of membrane filtration to enhance current wastewater treatment system. The presence of toxic metals like arsenic and copper on microplastic underscore the risk these pollutants pose to the ecosystem and human health. Current water treatment methods do not fully solve the problem, but using better filtration technique can significantly improve water safety. This research highlighted the need for new solutions in wastewater treatment to ensure clean water for the environment and public health.